There is a comet moving through our solar system right now, and its chemistry is quietly breaking a pattern that almost every comet was supposed to follow. It didn't form near our sun. It didn't form near any star you can point to in the sky. And when the James Webb Space Telescope measured the gases boiling off it, the numbers didn't match a single comet ever born in our own neighborhood. That mismatch isn't a glitch. It might be the most honest message we've ever received from another solar system, written not in radio signals, but in frozen gas that has been locked away since before the sun existed. To understand why a handful of gas readings has scientists this excited, we first have to understand what this object actually is and why catching it at all was almost impossibly lucky. Welcome to Infinity Alert. Today we're reading the chemistry of a frozen visitor that may be older than the sun itself. Almost everything in our solar system belongs here. The planets, the moons, the asteroids, the comets, all of them are held by the sun's gravity, looping around it on paths that repeat again and again. A normal comet swings in from the outer solar system, warms up near the sun, grows a tail, and then loops back out, only to return centuries or millennia later. It's a local resident on a very long orbit, but every so often something passes through that never belonged to the sun at all. An object that formed around a completely different star got flung out of its home system and has been drifting through the empty space between stars for an unknown stretch of time. We call these interstellar objects, and here's the part most people underestimate. In all of recorded human history, we have confirmed only 3 of them. The first was detected in 2017, the second in 2019, and the third is the object we're talking about today. That's the real problem astronomers have always faced. These visitors don't stop. They don't orbit. They come in fast, whip around the sun once, and leave forever. By the time our telescopes fully understood the first 2, they were already fading out of reach. Scientists got glimpses, not full portraits. What they desperately wanted was a third object, one bigger, brighter, and caught early enough that the world's best instruments could be aimed at it before it slipped away. This time, that's exactly what happened. On July 1st, 2025, a survey telescope in Chile, part of a global network built to scan the night sky for anything that moves, flagged a faint, fast-moving point of light. This network exists mainly to spot asteroids that could threaten Earth, so most of what it catches is ordinary local rock. But when astronomers traced this object's path, they realized it was doing something no local object does. It was moving far too fast to be captured by the sun's gravity, and its path barely bent as it approached. That shape, a sharp, open curve instead of a closed loop, is the telltale signature of something that is only passing through. It was confirmed as the 3rd interstellar object ever recorded and given a name marking it as number 3 in that tiny, exclusive list. Now, why does the shape of its path matter so much? Because the geometry of an orbit is essentially a gravity report card. A gentle looping path means an object is bound to the sun. A path that comes in fast, bends only slightly, and shoots straight back out into deep space means the sun's gravity was never strong enough to keep it. It's a tourist, not a resident. This object had one of the most extreme, most open paths of any interstellar visitor ever measured, moving through the inner solar system at well over 200,000 kilometers per hour. But speed and path only tell you where it's going. The truly interesting question is what it's made of, and that's where being a comet becomes the whole story. Unlike a dead, inactive rock, this object turned out to be an active comet. As it fell toward the sun and heated up, the frozen material on and beneath its surface didn't melt into liquid. It turned straight from solid ice into gas, streaming outward into a glowing cloud around the core. And that process is a gift to science. A silent rock keeps its secrets. An active, outgassing comet is essentially breathing out its own ingredient list, releasing gases that our telescopes can catch, split apart, and identify one molecule at a time. When you can read the gas, you can read the recipe. And the recipe is where things stopped making sense. The instrument that did the deepest reading was the James Webb Space Telescope, the most powerful space observatory ever built. Webb doesn't see the way our eyes do. It's tuned to infrared light, the range where warm gases and specific molecules leave unmistakable chemical fingerprints. That makes it almost purpose-built for exactly this job, pointing at a faint, distant object and asking, molecule by molecule, what are you made of? When Webb turned toward this comet, the first thing that stood out was the balance between 2 of the most common comet gases, carbon dioxide and water. Comets from our own solar system tend to follow familiar patterns in how much of each they release as they warm up. This visitor didn't. Scientists reported an unusually high amount of carbon dioxide relative to water, a ratio that sat outside what our local comets normally show. On its own, that single number is a quiet bombshell. It's the first direct hint that the environment this object formed in was chemically different from the environment that built every comet we grew up studying. Then the readings got stranger. Deeper in the infrared data, researchers reported detecting more fragile, more telling molecules, including signs of methane, along with water vapor and even the atomic signature of a metal. Methane is the interesting one, and here's why it's almost paradoxical. Methane is a light, delicate molecule. Leave it exposed to raw cosmic radiation for billions of years, the exact conditions an object drifting alone between stars would face, and it should be stripped away. Finding a clear signal of it on something this ancient is unexpected, so where was it coming from? The leading explanation is beautiful in its logic. Scientists suggest the comet's outer shell had indeed lost most of its original surface methane over billions of years of radiation exposure. What Webb was picking up was methane escaping from deeper material, layers that had been shielded, sealed, and untouched since before our sun ignited, now being exposed for the first time as the outer crust boiled off in the sun's heat. In plain terms, Webb wasn't reading this object's weathered skin. It was reading its frozen core. It was sampling material that has been in a chemical deep freeze since before Earth, the planets, and the sun itself existed. Webb wasn't working alone. NASA's Hubble Space Telescope imaged the comet to help pin down the size of its solid core, the actual rocky, icy nucleus hidden inside all that glowing gas. Measuring that is harder than it sounds because the bright cloud around the core drowns out the small solid center, so astronomers have to carefully model and subtract the glow. Their best estimates place the nucleus at a size noticeably larger than the two earlier interstellar objects. And that larger size is a big part of why this one was so much brighter and easier to study. More surface area means more gas released, which means a stronger, cleaner chemical signal for instruments like Webb to lock onto. Other observatories added their own pieces from different slices of the light spectrum, each confirming and enriching the picture the others were building. Now for the detail that reframes everything you've just heard. Based on how fast this object is moving relative to the average drift of stars in our part of the galaxy, scientists estimated how long it has been wandering since it was thrown out of its home system. The range they arrived at was roughly 3 to 11 billion years. For comparison, our sun and everything orbiting it is about 4.5 billion years old. Sit with that overlap for a moment. It is entirely possible that this comet is older than the sun. It may have formed around a star that lived its entire life and died long before our own star ever switched on. And every strange chemical reading Webb collected, the odd carbon dioxide balance, the hidden methane, the metal signature, is not a fingerprint of our solar system's formation. It's a fingerprint of a different one, a recipe from a kitchen that closed billions of years before ours opened. And here's what makes it almost unbearable to think about: the timing. Telescopes have existed for only about 400 years. Instruments capable of reading a comet's precise chemistry have existed for only a few decades. This object spent billions of years drifting in silence, and it happened to pass close to our sun during the one narrow window in all of human history when we had both the knowledge to recognize it as a stranger and the technology to read it in real time. A few centuries earlier, it would have been, at most, an unexplained smudge in the sky. We were alive, awake, and pointed at the right patch of darkness at the exact right moment. That's not a small thing. That's a coincidence stacked on top of a coincidence. So what does all of this actually mean? For the first time in a meaningful way, we didn't have to guess what another star system is made of by squinting at faint starlight from trillions of kilometers away. A piece of one came to us. We caught it, warmed it up, and read its ingredients directly. That has now happened only 3 times in recorded history, and this third visitor gave us by far the richest data of the 3, thanks to its size, its activity, and the sheer firepower of the instruments waiting for it. There's a bigger lesson hiding underneath the excitement, too. The fact that we've confirmed 3 of these objects in under a decade, with better sky-scanning telescopes still coming online, strongly suggests these visitors aren't freak, once-in-history events. Space may be quietly full of them, ancient fragments of other worlds drifting past us all the time, most of which we simply never had the tools to catch. Which means the next time you look up at a clear night sky, it's worth remembering. Somewhere out there, right now, more pieces of other solar systems are almost certainly passing through ours. Frozen, silent, and unnoticed, waiting for a telescope lucky enough to catch them before they slip back into the dark. We don't need to invent aliens or breaking news drama to make this remarkable. A frozen messenger, older than the sun, carrying the untouched chemistry of a star that no longer exists, measured, confirmed, and understood by scientists working together across the entire planet, is already one of the most extraordinary true stories in modern space science. Thank you for watching Infinity Alert. Stay curious, stay inspired. See you in the next journey through the universe.